Alright, so for number 1 is asking to dilate with a k equal to 1/2. Remember, k is your scale factor, so that is what we are going to do to our triangle. So remember, if k is less than 1, then we know, or your scale factor is less than 1, then we know it's going to be reduction. So once we actually draw our triangle, if it's not smaller, then we know we did something wrong. So first off, whenever you're given a figure on a grid, it's best to go ahead and get the vertices of that figure, so just get the corner points basically. So the corner points, I'm going to label their coordinates. So 1, 2, 3, 4. So it looks like -5, 2 is that one. Then we have 2, 2. And then we have 1, 2, 3, 4. So over 4 down 3. So that is +4, -3. So now that we have those, we can multiply all x and y coordinates by the scale factor, which is 1/2. So remember that multiplying by 1/2 is the same thing as taking 1/2 of the number. So if you want to multiply by 0.5 or 1/2, you can, but we will get half of all the numbers here. So the new coordinate is going to be -2.5, 1, because that's half of -5, and that's half of 2. And then this one's going to be 1, 1, if you multiply by 1/2 or take 1/2. And then we'll have 2, -1.5. So now if I plot those points, so -2.5, 1, that's over 1, 2 and 1/2, and then up 1 whole. So it'd be right there. So to get rid of all those marks, I'm just going to put it there. And then 1, 1 is here. And then lastly, over +2 down a box and a half would be right here. So now when you draw it, you should see that your triangle is a reduction. Hopefully you're using a straight edge, because that's kind of crooked. But yeah, so it's a reduction, which makes sense with our scale factor of less than 1. So number 2, I see the scale factor is 2. So I'm expecting a figure that's 2 times larger. So first, let me go ahead and write down all the corner points, my vertices of the figure. So we have -2, 1, -2, -1. We have 2, 2, and we have 2, -2. Let me undo that. Alright, so those are all the original coordinates. So now if I multiply them by 2, each of them by 2, I'm going to put it kind of higher because I'm not sure where this figure is going to be. It's going to be bigger than that. So I'm going to just write it up here at the top. So -4, 2, if you multiply that by 2. If you multiply this by 2, we get 4, 4. If you multiply this one by 2, we get -4, -2. And if you multiply this one by 2, we get 4, -4. Alright, so now I'm going to go ahead and plot it, and I'm going to put it in green just because I think I'm going to have to write over some of these coordinates that I wrote down. So we have -4, 2, which is here. We have 4, 4, which is here. We have 4, -4, which is here. And we have -4, -2, which is here. So when you draw your figure, it should look like it's 2 times larger, and hopefully, like I said, you use a straight edge because otherwise your lines come out crooked like mine. Alright, so there is our dilation with a scale factor of 2. It makes sense because it is 2 times larger. Alright, so number 3, it's asking us to set up a proportion and to match the corresponding sides to solve for x. Well, in this case, it's s, not x, but it's still a variable, so we can do it. So now, remember when you set up a proportion, you use corresponding sides. So 5 is to s, because those correspond, so we would set that up as 5 over s. And you set it equal to the other corresponding sides. So 3 is to 4.5. Notice if I started with the left triangle first on the first fraction, I've got to start with the left triangle first on the second fraction. So it's kind of like whichever triangle you start with between the two of them, that's the triangle you got to start with both times when you write the fraction. Alright, because if you see now, the information from the little triangles on top and the information from the big triangle is on the bottom. So it just has to be very organized. So now if we cross multiply, or multiply diagonally is like I like to say it like that, we get 22.5. And remember, you set it equal to the other diagonal. So the other diagonal is 3s. And so now that's a one-step equation. We just divide both sides by 3. And 22.5 divided by 3 is 7.5. So our S equals 7.5 right over here. So we know that side length is 7.5. Alright, now number 4. So one thing to notice about this, because some students get confused, they're like, so should this be mashed up with this, or should that be mashed up with that? So one thing to know or to look at is, some of you guys could probably tell which side just based off the length of the sides. Ooh, this side's a little bit shorter than this one. So therefore, if you look at it, this one's a little bit shorter than this one. So the shorts will go with the short. But if you don't see that, because sometimes they're very close in length, one thing you notice, you have parallel sides. Parallel sides. So when you have a parallel side and you have a diagonal, alternate interior angles are congruent. So because those are kind of like on other side, the opposite side of the figure, this is the left side, this is the right side. So since they're on opposite sides, it's going to be opposite sides that are corresponding instead of just the one right below it. So anytime you have alternate interior angles, it's kind of like the triangle got twisted around on the bottom. Okay, so I'm just going to take that away because we don't need that. So to set it up, if you see now, we have 6 is to x as, we could do 8 is to 12.8. We could do 5 is to 8. So whichever way you like to do it, you should get the same answer. So I'm going to do 5 is to 8 just because I don't want to deal with the decimal. So now when I multiply diagonally, right there I get 48, and then right here I get 5x. And so now if I divide both sides by 5, obviously it doesn't go in there evenly, but we could still get a decimal. So 48 divided by 5, I'm getting 9.6. So we got 9.6 equals x. And like I said, if you chose to use the other two sides as your second ratio, then, or the other pair of sides, then you would get the same answer. Otherwise, something is wrong with the problem. Alright. Now for number 5 and 6. So now we have this line that's cutting through the middle, so we have two separate triangles that are laying on top of each other. So we have this baby triangle right here, and that side lengths I'm going to put back that I know. So remember that 4 is the entire side, left side of that little triangle, and x is the entire side of the right side of that triangle. So that's how we have that labeled. So now when I draw the bigger triangle, I'm going to just draw it right underneath it. Picture's moving a little bit. I know it's not the best drawing, but you get the point. So this entire side, left side, that is 4 plus 7, which is 11 whatever long. If they have inches, they didn't really tell us a unit, but that side's 11. So remember, you always add up the entire side in order to see how long it is. Let me erase some of this. So from the tip to the other tip, or the vertice to the other vertice, that is 11 long. Now when you do the right side, oops, I erased my 11. When you do the right side of this, now we don't know x to know what to add to the 12. So we just write it as x plus 12. Because 12 is just from here to here. That's not the entire side of that triangle, the big one. So we're looking at this big triangle here. So if we're trying to get the entire side length, we're not just going to put 12 because that's only from one little segment to the other. So we write that as x plus 12. And now we can go ahead and write a proportion where we set up the sides in a ratio, corresponding sides in a ratio, set them equal to each other. So 4 is to 11, as x is to x plus 12. And of course, if you forget to do the x plus 12 and you just put 12, guaranteed that multiple choice option is going to be there. So you got to make sure you set it up correctly. So when we multiply, we get 4x plus 48, because I am distributing that 4 to both terms in the diagonal. Another way to look at that is you're doing 4 times the entire x plus 12. And if you see it that way, that is what I just did. I just distributed and got 4x plus 48. Now when I do the other diagonal, I just get 11x. So I'm going to set that equal to 11x. So if I subtract 4x from both sides of our equation, because I don't want to subtract the 11x, then there will be nothing over there. And you don't want to run into those issues. So I have 48 equals 7x. And then if I divide both sides by 7, we get that x equals, I'm just going to write it over here, 48 divided, not 49, it's almost, okay, so it's 6 point, put my equal sign a little bit better, 6.857, da-da-da-da, so we'll just round that to 6.9, round to the nearest tenth. Alright, so that's how you found x, or that's how you should have found x. Now, some of you guys may be like, oh, but I set it up differently and still got the right answer. Yeah, you could have done the short way and did 4 over 7 x over 12, only because those are on the outsides of the big triangle. The minute, if you try to do that and they put the x here, and then maybe a number, so I'm going to erase this because obviously it answers x right up here. Oops. Okay. I'm going to write x equals 6.9 up here, just so we remember. Alright, so the minute they put that x there, and let's say they put the 12 here, if you do 4 over 7 and x over 12 in this scenario, you will be wrong. So you got to make sure you just don't assume that you can do the number on the outside over the number on the outside, and then the number on the outside. You can't do it in parts like that in every scenario. So unless you know how to separate the two different types of scenarios, I would just make sure you always added the sides. Alright, so number 6. Oh, this is like very much the same example. You can't do 5 over 10 and 2 over x because that's not one triangle side to the other. And that's because if we look at just the little triangle here, we'll make it in pink. Yeah, that side lengths, those side lengths are there. So if I draw it here, we got 2 and 5. But then when we look at the big triangle, and I'll do it in blue, this entire side of the big triangle is not 10. 10 is only from here to here. If I want the entire side length, I need to add those two numbers up, and the entire side length is 15. So my big triangle, we have 15 on the side there, and we have x is just what's on the side here. That's not split into parts. So now I'm going to set 2 over x equal to, so 2 corresponds to x, and 5 corresponds to 15. And now I can go ahead and set it up and get my answer. So if I cross multiply, 2 times 15 is 30, and then 5 times x is 5x. So now my last little step here is to divide by 5, and we get that 6 equals x, or x equals 6. So that would be our final answer for that one. Alright, moving right along. So for this question, they're giving us some information they want us to find. So they want us to find PQ, which is this segment here, and they want us to find TP, which is this piece here. So they give us some good information. First of all, if you look at the side tick marks, these two and these two are congruent, and are those two markings, and this marking, that tells us that these two pieces are congruent. So basically what's happening here is the middle line that you see here, that is splitting this side and this side in half. Therefore we have what we called a mid-segment. Remember, a mid-segment splits the sides into 2 equal parts. So it splits both sides into 2 equal parts. So whenever we have a mid-segment, remember that the relationship is that the mid-segment length, so this length is half of whatever it's parallel to, whatever the measurement of the side it's parallel to. So if that's 30, mid-segment's 15. So that is our PQ. So PQ equals 15. Now on the side here, this is telling us that the entire length from T to U is 32. So if it's 32, but it was split in half by our mid-segment, this piece and this piece are congruent, that means it has to be 16 and 16 because it has to add up to 32 and it has to be the same number. So the distance from T to P, which is what we're looking for as well, is 16. And that's it on that one. So for number 6, we're solving for x. Once again, you should notice the sides are split in half. So if the sides are split in half, we know we have a mid-segment there. And remember, whenever you have a mid-segment, that mid-segment is half the length of the side it's parallel to. So one way of thinking about that is if it is half, then 2 of the mid-segments will equal the side length at the bottom there. So we have 2 of the x plus 19s will equal x plus 29. And now we just solve it as we would our equations. So we have 2x plus 38 equal to x plus 29. And then if we subtract x from both sides, so that we're subtracting the smaller one, bringing it to the bigger one, we have x plus 38 equals 29. So we can subtract 38 from both sides, and we get that x equals negative 9. Alright, and you could always check it by putting it back in, make sure it makes sense. So if I replaced x with negative 9 here, and forgot about what I put here, negative 9 plus 19, that would give me, that green's hard to see, that would give me 10. And if I replace x here with negative 9, this would give me 20. And that would make sense because if this is 10 and this is 20, you could see how the mid-segment is half of the actual segment. So x equals negative 9. Alright, so for number 7, it is asking us, do we have a postulate or theorem to say that these two triangles are similar? So remember, you have 3 options. You either have angle-angle similarity, that means you have 2 pairs of angles that are similar. You have side-angle-side similarity, so you have 2 pair of sides that are proportional with the angle, included angle, congruent. Or we have side-side-side similarity where all the sides equal the same ratio. So we're going to go ahead and check that here. So for number 7, we have, well, if you notice, the only thing on here are side lengths. The only thing. So we have no angle measures that we could work with on number 7. So we know that we're checking for side, side, side. Now don't just assume because numbers are on the side that it's side, side, side. You do need to match them up and see if you set the ratios equal to each other, if they equal the same thing. So I just matched up those two. I'm just going to choose to go in the order of small to big. So you just got to be consistent when you choose an order. So I'm going to say 15 is to 20, and I'm going to simplify that, and I know that if I check that in the calculator, if I divide both top and bottom by 5, I get 3 over 4. So I know I'm looking for all sides to have a ratio of 3/4. So now I'm going to try the other pair of sides. So I know this side corresponds to this side. So once again, I need to go from small to big. So from small to big, so that'd be 6 over 8, and that does simplify. 2, let's see, 2 goes into both, so 3/4. And then can't just assume because there's 2, then there we have the third, so we're going to check those. So we have small to big, 9 over 12, which that simplifies by dividing both by 3, so that's 3 over 4. So they all simplify to 3/4. Therefore, I do have side, side, side similarity. And now I just have to name it in the right order. So their order starts at G, goes up to N, and down to K. So I'm going to start at L, go up to A, and then go down to H. And I probably should put a triangle in front. Alright. Now for number 8, I do see angle measures, so I'm going to go ahead and check those right away because the quickest thing to get is angle, because you only have to check for 2 pair of angles. And as you see, this one is super easy. You have a pair of angles there. So you have angle C is congruent to angle Z. And you also have a pair of angles here. So you also have that angle A is congruent to angle Y. And so right there we have angle. Similarity. Ooh, that's the ugly squiggle. Okay, so then we have this order's ABC, so that's A across the bottom to B and then up to C. So we're going to start at the corner here, go across to X, and then up to Z. So triangle Y, X, Z. So now on the next page, we have number 1. We are looking to find the scale factor. Now remember, the scale factor is just the ratio we would get if we set corresponding sides equal to each other, or proportional to each other, or in a ratio. So I'm just going back to number 7 here. Our scale factor is 3/4 because that's what they all simplify to. So I'm looking for the scale factor, but remember it's very important the order here. So it says of RST, so right there I know that's my pre-image. So RST, this is my pre-image, to XYZ, so this is my image. Now remember, whenever you do scale factor, you have to do a side length from the image over the corresponding side length of the pre-image. So we have to do it in that order. So my image is this little one down here, because that's the second one they named. Anytime it's the second one, that one needs to go first in your scale factor. So basically, I just need to get a side length off of my image, which I'm just going to go at 2 because it's a nice solid number. Now, if you look at that triangle, though, let me erase some of this. You could see that it's kind of flip-flopped around. So 2 corresponds to 5. And you know what, one thing you could do to check that is look at the order they named it in. So if I pick XZ, which are the first 2 letters there in the triangle statement, then I need to look at RS. Sometimes if you get confused, ooh, what did I say? Oh no, I said the wrong thing. I underlined the wrong thing. Let's go back. XZ, which on the little naming here I underlined it wrong. So XZ is the first and the last letter, so I need to look at RT. There we go. Something didn't make sense there. Alright, so I'm looking at that, which is, it's obvious visually. So now I need to go from the image, that's going to be my top number, which is 2, the pre-image number, which is 5, and that doesn't simplify. That's as simple as it gets, so it's just 2/5. Make sure your scale factor makes sense. 2/5 is less than 1, so that is a reduction. And going from the pre-image to the image, that was a reduction, so it makes sense. If you had something greater than 1 as your scale factor and you look down and it was a reduction, then you know you have it flip-flopped. Alright, so letter B, find the perimeter of both triangles, and then find the ratio of the perimeters. So we're going to do basically what we did with the perimeters, but you have to remember that perimeter means the when you add up all the sides, so it's the distance around the figure. So basically we're adding up 2 plus 5, which is 7, plus 6, which is 13. So the perimeter here is 13. Now when you do the smaller one, 2 plus 0.8 is 2.8, plus 2.4 is 5.2. So now if we do our ratio, remember your order is still the same. You have to go from your image to the pre-image. So 5.2 is to 13, which you don't want to leave a decimal inside of a fraction because that's like weird. So if you actually divide that, you get 0.4, and then if you change that back to a fraction, you get 2/5, which you'll see that the perimeter scale factor or ratio matches the scale factor there. Doesn't always work for every measurement. For perimeter, yes, but if it was area, it would not be the same exact thing. So hopefully you guys looked at the relationship of the areas, which we did. All right. So now on number 2, they want us to draw a dilation with k equal to 2. So just like we did on the front, we need to look at the vertices. And is the dilation with scale factor 2, so we know it's going to be an enlargement. So the coordinates for C, let's see, I'm going to put on the side because our grid's kind of small. So -2, 0. The coordinate for A looks like it's 1, 1. The coordinate for B looks like it is 2, -1. So if we get all our primes by just multiplying, since our scale factor is 2, we're going to multiply all these coordinates by 2. So our C prime is -4, 0. A prime is 2, 2. And B prime is 4, -2. And now if we draw it, we can make sure it looks right. So that's -4, 0, 2, 2, and 4, -2 is here. So it should look 2 times larger, which, terrible drawing there, but you know, hopefully you guys will use rulers. Alright, so it does look like an enlargement, so it matches what my scale factor says it should do. So for the next one, this one, they're giving you both images, they want to know the scale factor. So typically it'll tell you you're going from like A to B, but we kind of left that information out. So we're going to assume this was set up for us to start at A in alphabetical order and go to B. Well, what is that? That's an enlargement, right? So I know this is going to be greater than 1. So now, what 2 things I could do? 1, I can count a flat side, a horizontal edge, or a vertical edge. So I can count this side, which is 2, or I can count this side, which is 2. You don't want to count diagonals because then you'll have to bust out the distance formula. So if you remember that, then have fun. Alright, so then this side is 1, 2, 3, 4, 5 boxes long. And this side is 1, 2, 3, 4, 5 boxes long. So remember that you go, this is our pre-image, this is our image, and remember scale factors, you always put the aftermath, basically your image number in the numerator, and your pre-image in the denominator. So 5/2, which is the same thing as 2.5, we know it's greater than 1, so it makes sense here that 5/2 is our scale factor. Not 2/5, because that'd be a reduction. Alright, so number 3, find the length of the missing sides. So we want to go ahead and set up a proportion just like we did before. So we can do corresponding sides. 4 is to 7. So 4 is to 7 as 12 is to x. Remember, if I started with the left triangle on the first fraction, I need to make sure I start back on the left triangle and write the second fraction. So 12/x. And then we can go ahead and cross multiply, etc. So there I get 4x equal to 7 times 12, which is 84. And now I can divide both sides by 4, and we get 21. So x equals 21. Alright, so now if it asked us to find like the length of side something and there was an expression there, we'd have to plug it back in, which I'll show you that on letter D. Alright, so letter B, same scenario. We have n and m though, so we have to set up a ratio for n and m, or a proportion for n and m, separately. So when we do that, let's just handle n first. So n is to 6. N is to 6. So notice I started with this little triangle first, so when I come back for another number, I have to start the little triangle again. So 3 is to 12. And then I could solve that. So cross multiplying, I get 12n equals 18. My hand hit the button there, so it drew a crazy line. Alright, so then we go ahead and divide on both sides by 12, and we get that n is equal to, if you simplify that, 6 goes into both, so 3/2. So for C, if you notice here, it's not a situation where you could just put 3/6 and this over this. This would be terrible practice. You would not get the right answer. So this is an example of where I was showing earlier where, let's see which one it was. Got all kind of ink on here. It was number 5, where you have to use like x plus the number or something, because if you just set it up like you could have number 5, it's not going to be the correct answer in the end because of it's the middle and the parallel side. So what we'll have to do is split it up just like I did before. Is we have a little triangle, which is 3, 3, so it's this triangle here, 3, 3, 4, and then you have the big triangle. So the big triangle's right side length, that entire side adds up to 9. And then we have the bottom side length is x, and then we have this side length that we don't know. We can't use x here because there's already an x. You could say y if you want, but we won't need that side because we're just solving for x, which is down here, the bottom, which I didn't mean to erase all that. So, and this entire side's 9, so I'm going to make a big triangle here. We have 9, and then we have our x here. So we have enough to set up a proportion because we have 3:9 as 4:x. So the key here was to add that side. If you didn't add the side and you did 3:6, then your answer will be wrong, and guaranteed it will be a multiple choice option because they're going to assume what you would do wrong. So we have 3x equals 36. So if you divide both sides by 3, you get x equals 9. So that is our x value. Now for letter D, once again, we have a mid-segment because, I know that's a mid-segment because the sides are split into 2 congruent segments. So I know that 2 of these middle ones will equal what we have on the bottom there. So 2 times 3x minus 1 will equal 34. So now we just solve. So we have, we have 6x negative 2 or minus 2 equals 34, and then if we add 2 to both sides we get 6x equals 36, and then if we divide by 6 we get that x equals 6. Now what you want to make sure you do is it may ask you not just to solve for x, it may ask to find the length of the mid-segment. So if it asks you to find the length of the mid-segment, you have to plug the 6 back in. So then you would plug 6 where the x is right here. So it'd be 3 times 6 minus 1. And that's if they ask for like the length of AB. So, or if they just ask for x, you just find x. But if they ask for a length, then you need to put it back in and see what you get. So the length of AB would be 17. So it just depends on what they ask for. You got to watch that. Alright, so for number 4, I think it's 4, cut it off, whatever that says. Determine if the following triangles are similar. If so, give the postulates. So here we are looking to see if we have either angle, angle, if we had side, angle, side, or if we have side, side, side. So this one, you should notice you do have a pair of angles, so you do have an A. Now it's the only A we have, so we also notice some side lengths. Now, if you look at this, you should notice that BA is a longer one and DE is a longer one. So I'm going to put 15 over 18 and simplify. So that simplifies to 5 over 6. And then I'm going to see if that equals the same ratio as setting 10 over 12. So 2 goes into both, so that's 5 over 6. So it does. So we do have corresponding sides are proportional. So that's a side, and this is a side. And then we have our angle. So we should see side, angle, side. So we know it's side, angle, side similarity. And I'm going to erase this so we can look at our order here. So they went from ABC, so from down the long side, ABC. So A, that's the 57 degree angle. So this is that corresponding angle D. So we should start off with triangle D. Then it goes down the long side, so it's a DE, and then to F. So hopefully you got that order. The next one, I see no angle measures in this. So immediately I'm going to try side, side, side. So the thing is just seeing which side corresponds to what. So obviously we have a bottom here. I'm going to try it with this bottom because it is not the shortest one. It's, you know, kind of like the second longest, and it's the flat one. So I'm going to go from small to big. So 6 to 18. And I'm going to simplify that. So that simplifies to 1/3. Now I'm going to do the short side in the small one to the short side in the large one, and that simplifies to 1/3. And then lastly, I'm going to do this slanted side, so that's 8, and the slanted side here is 24, so that does simplify to 1/3. So I notice that all three ratios are the same, so I do have side, side, side similarity. And if I name it correctly, let's see, they started off with G, they went to H, so they went across the bottom. So I'm going to go L to K. So triangle L, K, J. Alright, last one. I noticed that I have some angle measures, but I don't know what the missing ones are. So if I know this is 40, I also know that this is 40. And then, yeah, you have a 60 and an 80, but that doesn't mean that 80 can't match up with M. We gotta find M. So remember that all triangles add up to 180. So if we know that adds up to 180, well, we have 40 and 60 right there. Right there, there's 100 degrees. So the leftover angle has to be 80 degrees. So this has to be 80 degrees. So let me erase some of this because now it's messy. We know that this is 40. So that angle right there is 40. And we know that this angle right here is 80. So right there you should see we have a pair of angles, and we have another pair of angles with the 80 degrees. So this is our angle similarity. So we could say that angle MON is congruent to angle, if we just name our angles, POQ. And then our other angle, so that's these two angles here. I just named the vertical angles. And then we know that angle M is congruent to angle P. So angle M is congruent to angle P. So those are our two angles. And if we look at the order, they went from M to N, so along the short side, then to the middle. So I'm going to go P to Q to the middle. So triangle PQO. That's Q. Alright, so last question. So now we have a description, and I need to erase this so I can see it. Oh, let's just erase it all. Okay, so it's describing a flagpole. So here's our flagpole. It is 42.9 feet tall, so 42.9 feet, and it casts a shadow. Remember, shadows will be on the ground. That's 253.1 feet. So you should see when you have a shadow, you have a right triangle. And we want to figure out how long is the shadow that a woman casts. So we have a woman. Here's my woman. All right, she is 6.2 feet. Whoa, that's a tall woman. So she's 6.2 feet tall. And oh, how long is the shadow? So we're looking for her shadow. So that's our X. And there is our right triangle with that one. So you should see corresponding sides now that you could use to set up. So we could say that X is to 253.1 as 6.2 is. Now notice I started with the same triangle both times. So 6.2 is to 42.9. And you could have set it up differently. As long as you did it corresponding, you are fine. So we have 42.9x equals, so what that is, we have 253.1 times 6.2 equals 1,569.22. And then of course our last step is to divide by 42.9 on each side. and we get that x is equal to, and I'll put it over here, 36.578. So I'm just going to round it to 36.6 feet. Make sure you put units when we're talking about actual measurements. So that's how long we would expect her shadow to be. All right, and that is it. So hopefully you guys study up. Make sure you draw pictures. Make sure you separate triangles. Make sure you don't forget to add the side lengths. And be ready.